Now we talk about continuous random variables. So x is a continuous random variable if it has a distribution function which you can give as, so this capital X I'm going to write at the denominator. So this x is same as this x here. So this x comes from this x. So the distribution function is given as an integral. So it is integral of some other function, and this other function f of t, this f of t is called probability density function. Now this definition immediately implies, first is that going from minus infinity to plus infinity of this probability density function gives you 1. This you can easily see from the fact that we will rewrite this. You already know that 1 is equal to limit of x goes to infinity f of x, and this you can write as limit of x goes to infinity minus infinity to x f of t dt. So this side we are writing like this. So this x we write as infinity, which basically means limit of x goes to infinity, and this one we write here. Second thing is x lying in the interval from a to b is given as integral from a to b f of t dt. And third is d by dx of capital F of x is this small f of x. So this is fundamental theorem of calculus. So you basically differentiate both sides of this equation. Now this property 2 implies a very important property, that probability of x equals to a, that is x equals to a is also a less than equal to x, and x is less than equal to a. So this will be equal to integral from a to a f of t dt, and this will be 0 because you're integrating just a point. And notice that in continuous case probability of x equals to some point a is 0, but in discrete case this is not true. Simple example, you can say probability of x taking a head is half. Say if you have sample space head and tail, and the random variable is just identity on the sample space, that is random variable is also the same function as the sample space, it also takes values head and tail. So here it is half, here if you take any particular value you have 0. So now let us see this graphically. So this is the graph of the function f of t. So say t is here, then f of t is here. And when you talk about integral, so minus infinity is somewhere here. So say you pick up x here, then f of x is nothing but all this area on the left hand side of this line. So this entire thing is f of x. So it's up to you where you want to pick up x. You could have picked up x right here also, and in that case the area would have been all towards the left side of this line. So this entire area from minus infinity to this point x would precisely be the f of x. So f of x is the area under the curve. Now if you are just focused on graph of f of x, the graph of f of x looks like this. It always lies between 0 and 1. So the entire area is 1. So entire area under this green curve is 1, which you can see right here. So area under the entire curve is 1, and we just pick up separate points here to get f of x. So probability between 2 points a and b, this is just area between these 2 points. So let us see this again. So say you have 2 points, you have point A here and you have point B here, and this is the distribution function. So the probability between A and B, so this is the distribution function, this is the density function. So probability of the random variable x lying between A and B is given as the shaded area in blue. So this is the shaded area that this random variable x will lie between A and B. So that is what this means. So this is integral from A to B f of t dt. So this is very important to understand the difference between the distribution function and the density function. So random variable has two things associated with it. So you have this random variable capital X. It's better if I write, say, capital Y. So say you have random variable capital Y. Associated with capital Y, you have the distribution function, which is related to the density function by this formula. So notice that you have f of t here, this is the density function, and this x and this x match here. So corresponding to a random variable, you have two things which you should keep in mind. One is the distribution function, this side, and the second is the density function, which is this small f of t.